Hello everyone. In this lecture I shall discuss the harmonic function and will construct the analytic function, the conjugate harmonic functions, and this is also again in connection to these previous two lectures. It is again one of the most important lectures. Okay. Now if you recall the necessary and sufficient condition for analyticity, the necessary condition if f is analytic implies CR equation holds, provided these first order derivatives exists. Okay. Sufficient condition, CR equation together with the continuity of first order partial derivatives implies the analyticity of the function. Now from these conditions we have the following consequences. Consequence 1, if fz is analytic, then both u and v, both u means real part and imaginary part, both satisfy the Laplace equation. The Laplace equation is del square phi by del x square plus del square phi plus del y square is equal to 0. Okay. Here u satisfy also the Laplace equation uxx plus uyy 0, and v also satisfy the Laplace equation vxx plus vyy is equal to 0. Now these two are combined to give del square phi. This del square phi is the del square is the Laplace operator here, right? This is the Laplace operator here. Now consequence 2, basically we will focus on the consequence 1 and accordingly we will solve many important problems. Now consequence 2, if f is analytic, then the real part uxy equated to constant and imaginary part equated to constant both represent the orthogonal family of curves. We will discuss these two consequences, however we will focus on consequence 1. Okay. Now another important point of discussion here is a harmonic function. Roughly speaking, any function which satisfy the Laplace equation, right? Any function which satisfy the Laplace equation, as we told here that uxx plus uyy 0, vxx plus vyy 0, these are Laplace equation, okay, is called a harmonic function, right? So now we will see the connection between the analytic function, the harmonic function, and u and v. These are the harmonic conjugates. If one part is given, how to find the other? So before the details of the discussion, let me to introduce myself. Professor Susanta Kumar Paikray, currently working as a professor of mathematics. Susanta Kumar Paikray, working as a professor of mathematics at Veer Surendra University of Technology, Burla, Sambalpur, Odisha, India. So without much delay, let us now understand the connection between analytic function, harmonic function, and how to construct the conjugate harmonic function as well as the analytic function if one part is given. Now coming to the definition of harmonic function, any function satisfy the Laplace equation. Okay, satisfy the Laplace equation means uxx plus uyy 0, vxx plus vyy is equal to 0 is called a harmonic function, right? Or writing in details, any function of x and y which has the continuous first and second order partial derivatives and satisfy the Laplace equation is called harmonic. And simply this, okay, any function satisfying the Laplace equation is a harmonic function. So now in view of the above discussion, we find that if fz is analytic, then u and v are harmonic, right? U and v satisfy the Cauchy-Riemann equation from which we can derive the harmonic functions. We can derive the Laplace equation in view of the consequence 1. Shortly I will derive. So hence u and v, right, here u and v both are called the conjugate harmonic functions, or simply the harmonic conjugates or the conjugate functions. Now the major point of discussion here is, if u given or v given u minus v given, u plus v given, right? You find u given what is v and what is fz, v given what is u and what is fz, right? You this given and you are asked to find fz, and this fz is called the most general analytic function, most general analytic function, and as I have told you, u given find harmonic conjugate of u, right? So this u and v, these are called harmonic conjugates. So that means sometimes you are given one part, you are asked find the harmonic conjugate as well as find the most general analytic function. Okay, so in our major concern is to discuss the problems of these aspects. Okay, now let us prove here consequence 1 and consequence 2. Subsequently we proceed towards solving different problems. Now coming to the discussion of consequence 1, fz is equal to u plus iv is analytic. So this implies CR equations hold. So this implies ux is equal to vy and uy is equal to minus vx, right? If you differentiate it with respect to x, what you will get? uxx is vxy. Now likewise, if you differentiate with respect to y, what you will get? uyy is minus vxy. Now if you add this 1 and 2, okay, adding 1 and 2, you will get, adding 1 and 2 we get uxx plus uyy is vxy minus vxy. So this is equal to 0. So therefore uxy plus uyy is equal to 0. So that means here del square u is equal to 0. Right, this is u satisfy Laplace equation. Likewise, similarly we can see, we find vxx plus vyy is equal to 0. So v satisfy here, that is v satisfy the Laplace equation. Now if you mark, this is my star, okay, this is my star and this is my double star. Star and double star combined to give, star and double star combinedly give del square phi is equal to phi xx plus phi yy is equal to 0, which is the Laplace equation in general. Right? And similarly we have here Laplace equation in polar form. If you recall here your polar form, now if you recalling the Laplace equation in polar form, here ur is equal to 1 by r b theta. This is your CR equation. Now recalling the CR equation, you say, recalling the CR equation, Cauchy-Riemann equation in polar form, and ur is 1 by r v theta and vr is minus 1 by r u theta. Okay, the subsequent Laplace equation will be urr plus 1 by r ur plus 1 by r square u theta is equal to 0. So this is your Laplace equation in polar form, right? Laplace equation in polar form. So any function satisfying the Laplace equation is called the harmonic function. Now coming to discussion 2, let f is equal to u plus iv be analytic. So that means and let uxy is c1 and vxy is c2, right? If you differentiate it with respect to x partially, differentiate with respect to x partially, this differentiation is possible because analyticity implies differentiability, so this differentiation is possible. So what you are getting, del u by del x in plus del u by del y into du by dy by dx. Okay, by chain rule this is equal to 0, the derivative of constant is 0, right? So what is dy by dx? So that means here dy by dx is, this is minus of ux by uy, right? Uy. Now again if you differentiate this, now similarly if you differentiate it with respect to x, what you will get? You get dy by dx is equal to minus vx by vy. Let this is my m1, let this is my m1 and this is my m2. Now for orthogonality the product of the slope should be here -1. Okay, represent the orthogonal families of course. So what is m1 into m2 now? Here m1 into m2 is, so m1 into m2, so this minus sign this becomes plus, it is ux by uy multiplied with vx by vy. So here ux is equal to vy, right? This and this cancelled because ux is equal to vy and uy is equal to minus vx and uy, right? uy is equal to minus vx. So this, if this and this cancel, then there will be -1, so this is equal to -1. So since this product of the slope is -1, so they are orthogonal. Now in view of these results to be solved, we should derive another important result. One result is like this: if u and v are harmonic functions satisfying the CR equations, then in a region D, then f is equal to u plus iv is analytic. That means either you are given u, the moment we find that it is harmonic, right? The moment we find that it is harmonic, or first we find that it satisfies the CR equation, right? This u and so here u and v are harmonic. So u and v are harmonic means you have the existence of continuous partial derivative plus CR equation, right? This both thing will lead you to analytic function, right? If we prove this result, right, as u and v harmonic, so uxx plus uyy is equal to 0, vxx plus vy is equal to 0. We are finding the second order partial derivative means first order partial derivatives are continuous, right? Also u and v satisfy the CR equation holds, right? So continuity of the partial derivatives together with the CR equation, so that means fz is analytic. It is proved, right? Now our major concern is based on our consequence 1. In view of our consequence 1, the real and imaginary part of an analytic function, right, satisfy the Laplace equation or harmonic, right. So means now consequently, if here, as you know from consequence 1, real and imaginary part of an analytic function are harmonic. So now the moment u is harmonic, right, this implies u must be real part of fz, right, and if v is harmonic, so that means v must be the imaginary part of fz. So right, so the harmonic will lead you, so this fz is analytic, this fz is analytic, most general analytic function, right. So this harmonic behavior will connect you to the analytic function. That means if one part is given, we find the other part, and consequently, so in view of this, we are in a position to construct, right, construct the analytic function. So now this idea will lead to find the harmonic conjugates if one part is given, as well as lead to construct the most general analytic function fz. So now coming to construction of analytic function. So now during the derivation of your necessary condition, what we see here, f dash z is equal to ux plus ivx, right. Now in view of your Cauchy-Riemann equation, this is ux is equal to vy and uy is equal to minus vx. So this is minus iuy. This is because of your CR equation, right. Now this means this is in terms of u, so we get it in terms of u. So this is, we are getting in terms of u, right. This is in terms of u, so thus u is given, right. So accordingly, what is fz? Fz will be integration of this ux minus I uy, right, dz. So this is ux. So here ux, so now f dash is this, so fz how will get it? We will get it by integrating this, right, we will get it by integrating this dz, and here the x, in place of x you put z, in place of y you put 0, and in place of x you put z, in place of y you put 0. Now here u is given, if u is given, then we need to find v, and the constant here will be ic, right, I into c. So this is one aspect. So now accordingly, if v is given, then how to find? So now thus u is given, we are in a position to find fz. Now accordingly, if v is given, right, if v is given, then what is your f dash z? Here ux is equal to vy, ux is equal to vy CR equation, and uy is equal to minus vx. So this ux will be here, ux is equal to vy, and it is in terms of v, it is here plus I vx, it is in terms of v, right. So accordingly, what is your f? So this implies your fz will be, you have to integrate it, okay. Vy, it is a function of xy, in place of x you put z, in place of y you put 0, plus I vx is a function of xy, it is z and it is 0 dz. Okay, here we need to find u, so a constant just c is added. Okay, so now these two, right, these two are called the Milne's formula, right. This is a and this is b, right. If u is given, how to find fz? and how to find. V is given, how to find these two, A and B, formula A and B are the Milne-Thomson formula. So this formula A and B are the Milne-Thomson's formula. Thomson methods, right? So these are, so if either one is given, if U given, then we know how to find. If V given, then you know how to find. Let it be my I, let it be my 2I. Okay. So once we find FZ, then accordingly the conjugate function V or U can be obtained, right? So this is one of the simplest formula. There are several other aspects also, right? Other aspects also. Alternatively you have convert to exactness, right? Convert to exactness and solve. So another method, suppose your U is given. Okay, U is given. We have to find Vxy. Vxy you have to find, and you have to find Fz is equal to U plus IV. Okay, so now since we need to find V, so what is my dV? If you differentiate this V with respect to x, it is del V by del x by chain rule. Okay, del V by del x into dx plus del V by del y into dy. Right, now this del V by del x in terms of U, we have to write it in terms of U. Ux is equal to Vy, you know Ux is equal to Vy and Uy is equal to minus Vx. So Vx is minus Uy, so this is minus del U by del y dx, and here Vy is Ux, it is del U by del x, right, dy. If I say it is m dx plus n dy, let this be my m and this be my n. Okay, so now what is your m? M is equal to minus uy, and what is your n? N is equal to your ux. So del m by del y will be minus uyy, and del n by del x is your uxx. Okay, so del n by del x minus del m by del y is your uxx plus your minus plus uyy, but you know this is equal to 0 because your Laplace equation. So what we are getting? So that means del n by del x is del m by del y, right? So this equation here, this is your exact, right? This star is exact. Okay, so therefore equation star is an exact differential equation, and you know the solution of this. What is the general solution? The general solution is V is equal to integral of m treating y equal to constant plus integral of ny dy is equal to constant. Here terms not containing x. In that way you find V. So thereafter then you find Fz is equal to U plus IV. Similarly if V is given, right, you write U is equal to m dx plus n dy. In that way you write and you express it as an exact one. Okay, so this is alternative approach here, and another approach is direct. Another approach is from CR equation, right? Ux is equal to Vy and Uy is equal to minus Vx. Solve by interconnecting to get harmonic conjugate harmonic conjugate and FZ. Okay, but out of these three methods, this is third and this is my second, this is my second and my first. Okay, so I will prefer this Milne Thomson formula, as this will give you the easy aspects of solving the problem. So let us solve one example. Now coming to the most important questions. U is equal to this given, you have to find V, find FZ. Okay, so now first we have to see that whether the harmonic function or not, U is harmonic or not. Coming to the solution, here U is equal to x square minus y square minus y. So that means ux is equal to 2x, uxx is equal to 2, right? And what is uy? Uy is equal to minus 2y minus 1 and uyy is equal to minus 2. So you see uxx plus uyy, clearly uxx plus uyy is equal to 0. So that means U is harmonic. Once U is harmonic, so it must be, right? So there exists an analytic function fz is equal to u plus iv, of which u is the real part. Okay, u is the real part. So we are in a position to find v and fz. So what is fz? If we adopt the direct method here, right, direct method here, and we will see, then we apply the Milne-Thomson formula. By direct method, you have ux is equal to vy. So now, since this leads towards an analytic function, analyticity implies Cauchy-Riemann equation. In view of Cauchy-Riemann equation, right, in view of CR equations, right, here ux is equal to vy and uy is equal to minus vx. Now we have to solve in the view of v. Okay, so now in view of here, we solve it in viewpoint of v. Now vy is equal to ux we get it 2x, and here vx is equal to minus uy, so this is 2y plus 1, this is 2y plus 1. Let be my equation 1, let it be my equation 2. Now if I solve equation 1, okay, now my del v is equal to 2x del x, del v is equal to 2x del x, okay. If you integrate both sides, what is my v? V is equal to, sorry, it is del v 2y, because it is del v by del y, so it is 2xy plus a constant. It should involve the other variable. Since we are integrating with respect to y, the variable constant x here, right? So let it be my equation star. Now in view of this, here vx is equal to, what is here? Now directly, what is your vx? If you differentiate it, okay, it is 2y plus dh by dx. Now if we compare this, what is my vx now? Vx is my 2y plus 1. Now in view of this is my 2y plus 1. Okay, this is from 2. This is from 2. Right. So now what we are getting? This 2y cancelled. Means this dh by dx is equal to my 1. Right. So what is h? So that means dh is equal to dx. If I integrate, so my h is equal to x plus c. Okay. Now I substitute this. Here. Okay, this h plus c I substitute here to get my v. So what is my v now? V is equal to my 2xy plus h plus c. plus x plus c. So I get my v. After getting v, right, what is my fz? Fz is equal to, now my fz is equal to u plus iv. What is my u? So this u is my x square minus y square minus y, and my v is plus I, it is 2xy plus x plus c. Now you have to write it in the form of z. Now from the viewpoint of z, you have to put x is equal to z and y is equal to 0. Okay, so I am getting, so this is equal to z square minus 0 square minus 0 plus I times 2 into z into 0 plus z plus c. Okay, so this is your z square plus iz plus ic. Clear? So therefore fz is equal to z square plus iz plus ic. So this is your fz. So our desired v and fz are obtained now. So this is my v, this is my fz. Now instead of this direct method, if I adopt the Milne-Thomson formula, then we will see what is the result. So this is the formula for Milne-Thomson formula. This is fz is equal to this. This is your Milne-Thomson formula. Okay, so now in view of given u, what is ux partially differentiated is 2x. Now ux is a function of xy. So what is my ux z0? In place of x we put z, right? And here what is my uy z0? So in place of y it is 0. So this is minus 2 into 0 minus 1 is my minus 1. So now I substitute it here. So this is equal to, we have integral ux z0 is 2z. Okay, it is minus minus plus, so it is plus 1 dz plus ic. So that is equal to, you integrate it, z square by 2, 2 cancel, it is z square, and dz is your z plus ic. So your fz is equal to this. Okay, fz is equal to this. So this fz is same as this fz, right? Now we open it. Now we open it to get, v, right? So this is z means x plus iy square plus x plus iy plus ic. Okay, now if you open it, it is x square minus y square plus i2xy plus x plus iy plus ic. So now if you separate the real part and the imaginary part, here we have a I, so this is plus I. Okay, so this is iz, so this is I, right? So now if you separate it, we will be getting x square minus y square minus y plus I 2xy plus x plus c, right? So this is my v. So therefore what is my v? Therefore my v is equal to 2xy plus x plus c. So by Milne's formula it is quite easy. Okay, let us solve one more problem. Now you are given another problem. The real part u is given, it is given harmonic. So we have to find what is the value of a. After that we have to find the most general analytic function fz. Also we have to find the harmonic conjugate v. Okay, so let u is equal to ax square minus y square plus xy. So that means here ux is equal to 2ax plus y, right? And here uxx is equal to 2a. And what is your uy? Uy is equal to minus 2y plus x. This implies here uyy is equal to minus 2. Now as u is harmonic, so uxx plus uyy is equal to 0, implies 2a minus 2 is equal to 0, implies a is equal to here 1. Okay, so this a is equal to 1 is now substituted here. So therefore my, what is u is equal to my now x square minus y square plus xy. Okay, so what is your ux? Ux is 2x plus y. And what is your uy? Uy is minus 2y plus x. So to apply the Milne's formula, what is ux z0? X is equal to z, y is equal to 0, 2z. And what is uy z0? It is here y is equal to 0, x is equal to your z, it is your z. Okay, so by Milne-Thomson formula, what is fz? In view of your given ux z0 minus I uy z0 dz plus ic, right? If u given ic, if v given then c, then you simplify it. It is integral 2z minus iz dz plus ic. Okay, so this is equal to, you integrate it, this is z square minus iz square by 2 plus ic. So this is your fz. Okay, fz. Now if you simplify it, x plus iy square minus I by 2 x plus iy square plus ic, and if you simplify it, you will get x square minus y square plus xy plus I times here 2xy plus y square minus x square divided by 2, right, plus ic. So in this example you are given, this is your v. Okay, so we find vy. So now vy z0 we find. X is equal to z, means x is z and y is 0, we are substituting, right? So this is 0, this is 0, and your vx z0 is 4 zq. So this will be the Milne-Thomson formula. Milne-Thomson formula is this. So here vy z0 is 0, integral 0 plus I 4zq dz plus c. So this is equal to, right, so this is equal to I 4 z fourth by 4, it is z fourth, I z fourth plus c, right? So therefore fz is I z fourth plus c. So this is your answer. It is not asked to find what is your u, right? So this is your answer. Now this is a different question, right? So here instead of u minus v is given. So what you have to do, first you find ux minus vx. That means here del by del x of u minus v. So you apply the product formula, right? And this will be here 3x square plus 6xy minus 3y square. Let it be my equation 1. Then I find ux plus uy plus vy. Here we differentiate with respect to x. Now we differentiate with respect to y. So this is del by, this is minus. So this is del by del y of u minus v, right? Apply the product formula, and this will be here 3x square minus 6xy minus 3y square. Let it be your equation 2. Now adding 1 plus 2, what you are getting, ux minus vx plus uy minus vy. So this is equal to, ux is equal to vy by Cauchy-Riemann equation, ux is equal to vy, right, and uy is equal to minus vx. So now we add this 2, right? So now this and this added, it is 2 uy. This will give you 2 uy, because here minus vx is uy. So that is equal to your twice uy, and adding the right hand side. Here 6x square minus 6y square. Now subtracting 2 from 1, 1 minus 2, okay. Subtracting here 2 from 1, 1 minus 2. What we are getting? Here ux, so it is here ux minus vx minus uy plus vy, right? So here ux is equal to, so by CR equation this is vx, so this vx and this vx cancelled. Now you add this to ux plus ux, this is your ux, right? So this is ux plus ux, 2ux, so this is your 2ux. Adding, subtracting right hand side, you are getting 12xy, right? So what is your uy? Uy is equal to 3x square minus 3y square. Now uy z0 is 3z square minus 0 is 3z square. So similarly here ux is equal to 6xy. So ux z0 is equal to 0. Okay, now we apply the Milne Thomson formula. Okay, fz is equal to integral ux z0 minus I uy z0 dz plus ic. So this is equal to here, so integrating we are getting minus izq plus c. Okay, let us solve one more example. Now instead, if u plus v is given, then this is same, but here what we have to do, you have to do 2 minus 1, okay, 2 minus 1 you have to do. So this, after that you apply the Milne Thomson formula. Okay, this is what we have to solve, right? Coming to one more example. Here u is given and we have to verify that this is harmonic and you have to find v, right? So suppose another method I am using here, exactness I am using, okay. So let us see here. So what is ux is equal to 3x square minus 3y square plus 6x, and what is your uxx is 6x plus 6. What is your uy is minus 6xy minus 6y, so uyy is minus 6x minus 6. So therefore uxx plus uyy is equal to 0, implies u is harmonic, right? So now let v is equal to vxy. So what is my dv is equal to del v by del x dx plus del v by del y dy. So in view of this CR equation, so this will be your del v by del x is minus uy dx plus this is ux dy by CR equation. So now this is equal to, substitute the value of uy and substitute the value of ux, okay. So I am getting 6xy plus y dx plus 3 into x square minus y square plus 6x dy, right, dy, which is exact. So dv is equal to this is exact. So what is v? So therefore my v is equal to integral of this, treating y is equal to constant. So therefore your v is equal to m dx treating y constant plus integral ny dy is equal to c, term not containing x, okay. So this is equal to plus c. Here we, since we interested for v, we write ic. So that is equal to, we have integral of, if you integrate it, m dx. So treating y constant, it is x square by 2. So it is here 3x square y plus 6xy, and here only. So now this is simplified, and we are getting, we should add a constant here. So this is equal to 3x square y plus 6xy minus y cube plus 6. So this is my v. Okay, this is my v. So this is another method of exactness. Okay, now coming to some other easy way. If u is given, what is fz? We have another simple method to construct an analytic function if u is given. Okay, if u is given, right? If u is given, so if the real part u is given, then there exists an analytic function fz is equal to u plus iv, such that here fz is given by twice u of x is replaced by z by 2, y is replaced by z by 2i minus u0 0 plus ic. So coming to this question, solution I. So this is my u, right? What is u0 0? So this is your 1. Okay, then what is my u? Z by 2. I write fz is equal to u z by 2i's u z by 2 z by 2i minus u0 0 plus ic. So that is equal to, I can write twice, here x is replaced by, what? X is replaced by z by 2, and y is replaced by z by 2i. So this is equal to twice z by 2 whole cube minus 3i z by 2 z by 2i square plus 3i z by 2 plus 1, and here it is minus 1 plus ic, right? Because minus 1 is u0 0 is this. Now if I simplify it, it will be my 1 by 2 z cube plus 3 by 2 z plus 1. Okay, so this is the answer. Is that not easy, right? It is very easy then. Similarly, coming to your solution 2i. So here what is your u0 0, x0 and y0? This is 0. Now fz is equal to 2i's u z by 2 z by 2i minus u0 0 plus ci. So that is equal to your twice your yq is z by 2 whole cube minus 3 z by 2 whole square into z by 2i minus 0 plus ci. Now if I just simplify it, it will give me izq plus ic. Okay, coming to solution 3. Here u0 0 is your 0, so therefore fz is 2i's u z by 2 z by 2i minus u0 0 plus ci. If I simplify it, it will give me sin z plus ci. Okay, now let us see some standard analytic functions. Now you see some standard analytic functions. Okay, suppose here ln z is equal to ln r e to the power I theta is equal to ln r plus ln e to the power I theta. So this is equal to ln r is your z mod x square plus y square root over plus I tan inverse y by x. So if this is your u, then this has to be your v. Okay, then coming to here, suppose e to the power z, it is e to the power x plus iy is equal to e to the power x cos y plus I sin y. Accordingly we will find u and v. Coming to 3, e to the power minus z, e to the power minus x, it is cos y minus I sin y. Okay, suppose here e to the power iz, it is e to the power I into x plus iy is e to the power minus y I into e to the power ix. So e to the power minus y cos x plus I sin x. In that way, suppose here 1 by z. 1 by z is not, 1 by z is given. It is except at z is equal to 0. Okay, it is 1 by x plus iy. This is x minus iy by x square plus y square. Okay, so this is x by x square plus y square minus iy by x square plus y square. Here z is not equal to 0, right? Z is not equal to 0 here, right? Z is not equal to 0, and here similarly z is not equal to 0 here, right? Similarly, coming to your 6, sin z is sin x plus iy, sin a plus b. If we apply it, it will be sin x cos hyperbolic y plus I cos x sin hyperbolic y. Accordingly, right? Accordingly, if this v is given, you can find u. So these are the standard functions. So just looking into either u or v, we can directly say the answer. Okay, so directly answer can be viewed by inspection. Okay, coming to an important question. If u and v are conjugate functions, then the product uv is a harmonic function. Okay, so let us prove it. Since u and v are conjugate functions, we have uxx plus uyy is equal to 0, vxx plus vyy is equal to 0, because these conjugate functions are harmonic functions. Okay, also CR equation holds also ux is equal to vy and uy is minus vx by CR equations, right? So let phi is the product of these functions uv. So this implies, what is my phi x? So this is uvx, product formula, plus vux. Now I partially differentiate twice. It is uvxx plus 2uxvx plus vuxx. Okay, then similarly my phi yy is equal to uvyy plus 2uy vy plus vyy. Okay, so now in view of this, if I substitute this here, CR equation, it will give me uvyy minus 2vxux plus v, this is vuyy, this is vuyy, just 1 second. So this is vuyy. Now if you add phi xx, this plus phi yy, so this was u into vxx plus vyy plus vuxx plus uyy. So this is u into 0 plus v into 0. So this is equal to 0. So that means phi is equal to uv is harmonic. So as you discuss, the main importance of this chapter, of this lecture here is u given, v given, you find u plus v given or u minus v given, and you need to find what is fz, right, and what is the other conjugate function. So now we have discussed so many things. One is the direct method we have discussed. One, you have by exactness we have discussed exactness, and by using Milne Thomson formula. And finally, if u is given, then your f is equal to 2i cu of z by 2 2i minus u00 plus ic. Okay, plus ic. So these are the things you have discussed. So this Milne Thomson is easy aspects, and this is again easiest. easiest, but it is only for you, right? Milne Thomson is easy. So according to you, whatever method you prefer, you can adapt. All the methods we have discussed. The video is lengthy because we have discussed so many examples. Okay, because these analyticity, Cauchy-Riemann equation are most important. These are the pillar of the complex analysis. Okay, so in the next lecture I shall discuss, in the upcoming lecture I will discuss here complex integration in the upcoming lecture. Now if you feel this lecture is useful and interesting, please like and subscribe to this channel, which will boost my motivation to upload subsequent lectures for your benefits. So thank you all for your patience listening to this lecture. Thank you once again.